Hello, this is Sergio Cicero from University of Cantabria, and I'm going to present the work entitled Graphene oxide does not seem to improve the fracture properties of injection molded polymer 6, PA6. My co-authors are Jessica Lorena Parra, Borja Arroyo, and Isabella Procopio, all of them working at University of Cantabria. The contents of the presentation are divided into these four sections. First of all, an introduction, why we decided to develop research on this topic, materials and methods, results and discussion, and finally the main conclusions. If you perform a literature review on the effect of incorporating nanoparticles into different matrix, like polymer matrix, composites, ceramic matrix, metal matrix, composites. There is a general feeling that when you introduce such nano particles, the behavior of the material improves. And here we are talking not only about mechanical properties, we can talk about conductivities, optical properties, thermal properties, etc. Here, the analysis is focused on mechanical properties only. The rest of properties are not analyzed. And within mechanical properties, we will focus especially on fracture properties and notch effect. When analyzing the effect of nanoparticles on mechanical properties, it is generally the analysis is basically focused on tensile, not on fracture. But as I said, the general conclusion in most of the works available in literature is that nanoparticles improve the properties. So, encouraged by these results, and given that we had some experience on PA6 material, we decided to analyze what happens if you introduce nanoparticles in PA6. And the nanoparticles used in our analysis is graphene oxide, which is one of the most commonly used. So what we are going to analyze at the end is how the introduction of graphene oxide in PA6 modifies the fracture behavior of the material, of the matrix, in cracked and notched conditions. And we distinguish between cracked and notched conditions because obviously notches do not behave as cracks, and it is necessary to specifically address the behavior of notches by developing methodologies to analyze this particular type of defects. So these are the materials that we are analyzed. Polyamide 6 with graphene oxide. With graphene oxide contents of 0 weight percentage, 0.25, 0.50, and 1 weight percentage. The pure polyamide, the pure pH 6, and the 1% graphene oxide content materials were provided by a producer in pellets. Obviously, 0 weight percentage material has no nanoparticles, and 1 weight percentage material pellets had the the graphene oxide already dispersed in the material, and this dispersion was developed and ensured by the material producer. To obtain, for example, the 0.50 weight percentage material, you just have to mix 50% of pellets of pure polyamide and 50% amount of 1 weight percentage material, 50-50. If you want a 0.25 weight percentage material, you have to mix 3 parts of pure polyamide and 1 part of 1 weight percentage material. So the mixture of the pellets, the corresponding mixture was performed, and these pellets were introduced in an injection mold machine, and the specimens were tensile specimens like the one on the top in the figure were injection molded. Some of them, just as a few of them, were used for tensile test, and the other specimens, up to 80 specimens, were cut in the middle section to obtain the fracture specimens like the one shown in the figure on the bottom part. So we are mixing different amounts of graphene oxide in the material, and different notch, really, from 0 up to 2 millimeters. And because we are dealing with notches, we are also going to use the theory of critical distances, and particularly the line method, which combined with the Cracker-Paris notch stress tip distribution provides us the expression from the apparent fracture toughness shown below, where the apparent fracture toughness is equal to the fracture toughness multiplying the square root of this factor shown in the slide. So, which are the results that we have obtained? Here you have the tensile tests. You see that the upper curve corresponds to pure polyamide. So it is quite clear that graphene oxide does not improve the strength of the material. When we have introduced nanoparticles on PA6, the Young modulus has become lower generally, and the yield stress and the ultimate tensile strength have been also lowered. On the contrary, the ductility seems to increase a little bit, and because fracture toughness is at the end a compromise between the strength and ductility. At this stage of the research, there were doubts about whether or not the fracture toughness was going to be improved when including nanoparticles. Here you have a summary of the results. You see that the yield stress has a tendency to be reduced when including nanoparticles. The Young modulus actually is not very sensitive, except for the case of 1 weight percentage. The ultimate tensile strength, there is a typo there, which is the second column from the right, is rather constant as well, but it tends to be lowered when including nanoparticles, and the ductility has certain increase when including the nanoparticle. Here you have some examples of the low displacement curves obtained when in the fracture test. You see that the curve for the pure polyamide is much more linear, and this linearity decreases when including the nanoparticles. We represent the apparent fracture toughness. We follow the corresponding fracture standards for composites, and you see that you may see that on the paper. The evolution of the apparent fractal toughness is shown in the figure, where it is clear that the higher is the graphene oxide content, the lower is the result in terms of apparent fractal toughness. We have adjusted these curves by using the line method expression just to have a much clearer picture of what we are. Here you have the results. I mean, the effect of the graphene oxide is clear. The fractal toughness reduces. The notch effect, the increase in the fractal resistance with the notch radius is quite similar in the different materials. Actually, you have on the paper the critical distance values for the materials, and they are quite similar for the four materials. But it is clear that there is no improvement at all when introducing nanoparticles on pH6, which is surprising if you look at the literature, and it has been quite disappointing for us, to be honest. But I mean, publishing these results, it may save quite a lot of effort in terms of time and money to other researchers. We thought it was important to show our results. Of course, these results depend on the type of polyamide, on the type of fabrication process. This is injection molded material. I mean, other types of fabrication processes may lead to different results, but in our case, these are the results. So, graphene oxide generates a slight reduction in the strength properties of pH6, as well as a slight increase in ductility. Graphene oxide does not improve the fractal resistance. On the contrary, the highest fractal resistance has been observed in pure pH6. Graphene oxide does not significantly affect the notch effect observed in pH6. The sensitivity of the material, of the resulting material to the existence of notches is quite similar in the four materials being analyzed. And these conclusions are restricted to tensile and fractal properties. Other material properties have not been analyzed in this work. So thank you very much for your attention, and I'm now open to any questions from the audience. Thank you very much.